Welcome back to the Pareto Learner. Today we're diving into the world of data science, and we will learn something very simple and very efficient, which is called regression analysis. And starting off with linear regression, so I've got my Visual Studio all set up. First, let's cover the basics. Regression analysis, as you might know, is a powerful statistical method that we can use to find relationships with dependent and independent variables. First thing we've got to do before we get started is import numpy and as np, and then we're going to go import pandas as pd, import matplotlib, and then import Seaborn. And finally, from scikit-learn, we will add the model selection and import the train test split. And from scikit-learn, import the linear model, which we're going to use, and we're going to use the linear regression. From scikit-learn, we will import the metrics as well, which we require for the mean. And basically now we've imported all the libraries, numpy, press play on Visual Studio, and everything is good. Now that we've got our libraries installed, we can get down to the sample data and visualize it. First step, usually when we're doing some kind of data analysis, visualization is probably the best place to go first. So we'll use the Boston housing dataset for this example. The dataset contains information about housing prices in Boston. So let's just comment this a little bit here. And from scikit-learn, we will pick up the datasets. So we'll import those and import load Boston equals to load. We're going to convert this data to data frame, and then we're going to resource it to pandas. So let me just add here data frame, and to convert it we're going to say data frame, and from data frame we're going to get the Boston data, and from the Boston data we're going to go to columns, and the columns will be Boston feature names. This data set do this too much, so we know that price got Boston target. Now we can quickly visualize the data set Seaborn, and we'll consider the x variables for Boston feature that we've got, and for y variable we'll consider price. Plot, let's give height. Let's see, pretty much good. Basically, t show. We know that this is working fine, and we've loaded the data set to our system. With our data visualized, we're now interested in doing something else. For simplicity, we'll just use the two features that show the clear linear relationship in the data set we've got. Usually there's a lot of, in this case, we'll use the variable rm, which is the average number of rooms, and lstat, which is the lower status population. So to do that, we will just allow us first to show top features, and once we've done that, we can define as x equals data rm and lstat. So these are the two variables we're going to use, and y we are going to use, as we've mentioned, price. Okay, so now that we've defined both of these variables, split the data set into training site, split this data into training and testing sets. That means that we're going to use x train, x test, y train, and y test, and this is going to be equal to the train test split x, y, and test size. We'll do 0.2. We will consider 42 for the sake of the argument. All right, let's see if that works out, if there are no errors. So let's call this the create and train the model that we're doing for the two variables. So model is linear regression, model fit is the x train and y train. This allows us to then train our model, and once we've trained it, we can basically start evaluating its performance using the test set. So we'll calculate the mean squared error to quantify the accuracy of our predictions, and to do this we can go with make predictions, call this like y prediction, and this is equal to model predict x test, which we've defined, and from this we want to calculate the mean error. So let's go and say calculate the mean squared, and we will do this as, let's call it mean squared error of y test and y prediction. So I can say print f, and mean squared error is the MSE to f. Okay, so we get a mean squared error of 3124. And that is it. Basically, we've seen how linear regression works and how you can apply it